Hello everyone, it's October 13th. Alright, let's do this. Oh, 2 in a row, which means we gotta check the other answer. Adjacent increasing subarray detection. Given an array nums of n integers and integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b, where both subarrays are strictly increasing. The subarray must be adjacent, meaning b equal to a plus k. Return true if it is possible to find two such subarrays, false otherwise. Two subarrays of length 3. Okay, 7, 8, 9. Yeah, I see it. 7, 8, 9. 2, 3, 4. So basically we'll have 1 as we go through, increasing, and strictly increasing. So if I have increasing, strictly increasing, the length is larger or equal to 2 times k, and that's definitely true, right? So if we go through, the current stretch is 2 times k, larger than 2 times k, and that's definitely a true. Now if not, what will happen is it will go up, then it will go down. So when it goes down, it has to be like increasing again. How about we find just the stretch? What's the length of the stretch of increasing? Right? We just find the stretch of the longest increasing. So like in this example, right, we go 5, 2, 5, 7, 8, 9, 2, 3, 4, 3, 1. So if we go here, so 1, 2, 3, 4, 5, I have 5. 1, 2, 3, I have 3. And this is a 1, and this is a 1. This is what we have, which tells me there is 5 strictly increasing, 3 strictly increasing, 1 and a 1. So as long as, so once we get this number, all we want to know is if, so like we get this, we check if it's larger than 2 times k, we're already done. If not, we'll go for the next one, and once the next one's out, we just check if this one is larger or equal to k. If it is, we check the one before. If both are larger or equal to k, we're done. If not, then we're not. Which is here we have strict increasing. So it's 1, 2, 3, 4. Right? 1, 2, 3, 4. And then we're not increasing 1, 1, 1. Because that's a 1, because it's not increasing, so we reset. Not increasing, this is a 1, not increasing. But this is 4. So yeah, it doesn't work. Okay, let's try this. find the length of subarray of the longest subarray with strict increasing numbers. If the length, find the length of the consecutive, the length of the current subarray. Yeah, if the length is larger or equal to 2 times k, we are done. Otherwise, if the current length is larger or equal to k and the previous length is also larger or equal to k, we're done. All other scenarios will lead to false. So we'll say int pre is equal to 0, and then we just say current, right? Current is equal to 1, so I have 1. And then for int I equal to 1, I is smaller than nums plus size I plus plus. If nums I is larger than nums I minus 1, we say current plus plus. Else it's not. Then we'll have the current. We say if current is larger or equal to 2 times k, we'll return true. Otherwise, if current is larger or equal to k and pre is larger or equal to k, return true. Otherwise, yeah, we set current equal to 1. And then we'll keep going. Right, keep going. And then once the last one, okay, the last one is done, and then we get out, we check again. Maybe you want to add something to nums, so we don't have to check again. Yeah, I think it'll be easier if nums dot pushback. I think the smallest is 1000, so we do 1001, which means the last one is definitely not going to be possible. So we have to do this check. And if all is not possible, we'll return false. Okay, so we'll use this. The first one is bad. Oh, because I forgot to set the pre. Yep. Why 3 milliseconds? Don't understand. Okay, so that's that. We'll check this. Oh. All right, so what is this one doing? Total count. Target odd numbers. Target odd. So remaining odd needed. This is the remaining needed. K is the number of bits. It's the number of bits needed. Index. Carry. Total count numbers from the list so that exactly this number are odd. Huh? How many are odd? That's an interesting way of phrasing it. This is the number of set bits, right? Number of set bit is corresponding to the number of odd number, or their effect. Why number odd? Keep track of binary carry as we combine numbers. Remaining carry. And remaining is 0, so we pick everything. And odd needed is equal to carry. The carry matches the target. If it matches, return 1. think it's if you remain like you remain so total count of this starting from here with this amount of carry. Carry is just, I think, the previous, right? Previous coming to you. So now you can do some picking, and then once you pick, and this should be a sum of all of those things together, right? With those remaining, okay, so with those remaining, what we want to compute is the reproduct of this. So if I have nothing remaining, if we have nothing remain, why you return 1? You return 1 because it is a successful case, right? It's a successful case. So we have remaining, we have take these much. We can take 0 all the way to there. So in combination, remaining would take, and nums intake, take is the current index. So this is the current index taking how many times? That's not true. Ways. New carry is carry plus take. So the carry is the higher level bits. That's the carry, the higher level bits. The odd needed is the number of bits needed minus the carry, because we are going to shift. We're going to shift to right. So every time we shift to right, we have 1 that's been handled. So odd needed minus 1. And new carry is the remaining. And then ways times, this is the next one. So whatever this we have, we say the current one can take that much, right? Because of the question. If I take it multiple times, yes, it makes sense, because we have these remaining, but we can take them in different orders, right? We can take them in different orders, and we have that many times a combination of taking, and then each one will have the same amount. Yes, and then whatever we have further down, we just need to multiply that. Yeah, that's true. And then we'll add it. We'll add it, and then we do this. Okay, I can see. I do think this is not as clear, actually. I actually used what I read yesterday in order to understand what this carry is and what this like the relationship between this and this, right? The carry is so basically each time we will remove the last bit, because the last bit is determined. Because as we move on to the next bit, we will move on to the next one, right? And we're moving on to the next one, to the next index, because the index just goes up, right? We move on to the next index, which essentially is the higher bits. We'll go for the higher bits. And when we go for the higher bits, the lower bits are always determined. So that's why we can do this. The carry is just a bit mask of the higher bits. So we do this, so we get the new of this, and then because we handle the lower bits, we need to do a right shift. So yeah, essentially it's the same, but because it's a Python, you don't have to do the quick multiplication, which actually is a misnomer. This is a modulo. This is a modulo power, right? And also you don't have to do and all this because we are not really relying on the combinatorial. What we are relying on is quite straightforward. We're using this. Right, we're using this, and then yeah, this power replaces all that, and we use this. Essentially, this is replacing all of this, so we don't have to write the combinatorial ourselves. We can use this, and this will give us. Okay, yeah, I see. It's the same, but in Python it's just much easier. Yeah, it's just much easier. And if you think about it, it's essentially the same. 4 levels, right? This is 4 levels. This is also 4 levels. Yeah. But again, 4 levels. I mean, the state. I don't know if I can even come up with this, but. So these two, probably if I think hard, maybe I can get them in. But index maybe. But this ideal of carry, or in this case, I think it's more clearly explained. The ideal of the higher bits, the bit mask of the higher bits values. This is just an idea. Remarkable. I think it's a remarkable idea. Yeah, I think it's a remarkable idea. I don't think I can come up with this. All right, anyway, so we go through this. I think most of the solutions should be about the same. But yeah, I don't see any chance, okay? Any chance of me solving this. And I'm also pretty sure this will not show up in any interview. This is way too hard. Like, what does this test? It does not test anything. It tests, okay, it tests your ability to do DP, but that's pretty much it. I mean, the thing is, if someone use this as an interview question, like, how do you expect? I mean, I guess depending on your expectation, right? If your expectation is for the candidate to really solve this, yeah, I think that's a very poor one. I don't think anyone, minus those very, very, very well studied in this, I don't think anyone can solve this. But if the thought process, maybe.